and our topic is making machines dream. अभी इतने बजे लंच करके उसके बाद तो सोना ही आता है ना, तो चलो हम लोग let's dream now. So let's not take a nap and dream, let's make machines dream. Okay, so as you all know, we are all aware of the concept of machine learning, and in machine learning we know machines learn and they make decisions for us, right? So now it has come to a level, to this situation, that we can make machines dream, and the observations which the machines make, and we want the machines to dream for us. Like we dream, we see a lot many things in our day-to-day life. Like suppose we have seen today, you people are here, you see me and you had a great lunch, you see you're there in Mayfair and you go back and sleep at tonight. Obviously you will be, visualizing all the things which you have gone through in a daytime. So similarly, we have seen in machines, when the data we are feeding into the machine, all those data, how the machines interact and how the machines react to all those data and start dreaming of it. So let's have a tour of how machines dream. So we all know machines host every application, any random application you take up, it's hosted on a machine, right? It may be a virtual machine or it may be a hardware machine. Machines compute. That is a Hadron Collider. This is airlift simulation. You all know about it, and the virtual reality. Now computations are done by machines, okay? Now coming to machines learn. So this is a nice video in which what the scientists did is, this is a virtual sensors attached to this system, okay? These are the virtual sensors, and they fed in the data of the obstacles around and the information which is given about the obstacles around of that and the orientation it needs to make, and they left it to move from point A to point B, and this is what it did. It learned from itself, from the mistakes which it makes, and started jumping, started walking, started crawling. These are the things which it could do. So it sees the obstacles, it jumps out of it. It sees the obstacles, it sides and makes its directions. Okay? So you're getting a clear picture, right? This is how machines start learning from the data which we feed in. Okay? And this is how the machines dream. As I said, whatever we see today, right? You can see so many things in this video, right? They're humans, they're animals, you'll see some cars, it's not clear, but you'll see some cars, you'll see some objects, anything. So these are the data fed into the machine. So machine को जब ये सारे data दिया गया है and it was asked to dream, this is what it dreams. It sees for a human body, it attaches an animal's face. So this is what, it is a random dream which the machine is seeing, as we see, right? Okay, now machines learning by example. All of you are aware of this autonomous vehicle which is hype in the market today, right? So this is what it does. These are the observations fed into the machine. These are the data information which is fed into the machines, okay? And applying the learning algorithm, what the machine does is, it does the segmentation. You can clearly see from the roads, it segments the road, it segments the human, it segments the signboards, the traffic lights and the cars also. And from the segmentation, it does the object detection. You're all aware of that fact that machines can do object detection, right? So this is what it does, the object detection. And when it does the detection, it starts making the decision, what it needs to do. This is the concept behind the autonomous vehicle. This is learning, machine learning. We have yet to know how can machine dream, right? Now, you saw from the observations, what the machines make is patterns. They make a pattern. The segmentation and the detection are a part of the patternization of the machine which it makes. And from the patterns, what it does is, it makes the decision. This is learning, machine learning, right? Where now comes the machine dreaming. Now suppose we see the observation and the machine makes the patterns, right? Now, if we backpropagate from the patterns, if the machine can make observation, that is dream, right? That is dream. So this is the flow, very basic funda of how the machine can dream. Till today, it was observations, patterns and the decision. The fact was just like that the machine was doing. Machine was learning. Now it's time when the machine needs to dream also for us. This is the concept of machine dreaming, right? Okay. So this is the example which we saw for machine learning, right? Now we'll see the the example of machine dreaming. Now you can see that is a summer road. Suppose we take it, this is the summer road of Switzerland, right? And what this is the autonomous vehicle will see, it is a summer road, right? Now There might be winter in, there will be winter in Switzerland also, right? So do we need to feed in how the roads will look like for the, winter for the machine? Let the machine dream. Why will we feed? Let the machine know. We will feed in the information that machine, what is winter and how the winter is in Switzerland. And what it does is this. This is how the machine dreams. We'll see a real-time example. This is how the machine dreams. For a summer road, you can see the exact road and it detects how the machine, how the road will be in the winter. Similarly, in the winter, it will make for the exact same place as a summer place, right? This is the machine dreaming. This is not the data fed into the machine. Now, we come to a point, why do we want machines to dream? Right? We have come to a place like machine is doing everything. Why not let it dream? Why will we feed in data? We have already collected so many data. Let the machine dream out of the data and create some, wonders. Okay. So all are aware of this Prisma, right? Which was hype in Instagram and everything. You click pictures. So what it does is, this is the content image which we have. This is the styled image. Okay. And what the machine algorithm will do, it will dream the image combination of this content and the styled image. Applying the machine learning algorithm, it will dream of the image like this. You see, the image is the same, the content image is the same, but the style has changed, right? This is the concept behind the Prisma. Okay. Now another concept is image in painting. Now we have seen many applications, we mask a part of the image and it blurs or it does remove that place. It creates a mask out of it. But what the machine, that is machine learning. It knows that if we create a mask here, it will just remove that place. But does the machine know that we have masked my eye and it needs to replace that mask with an eye? That is machine dreaming, right? So you see this example, sorry. Observe it clearly that it has marked the eye. Did you see the change? The other eye, this human body will entirely change. The machine now knows that we are masking the place in the head, the hair. So it knows that that place is hair. I need not remove it. I need to replace with another hairstyle which that man can have. This is not masking it. This is replacing the exact chin, exact skin color tone. The machine is knowing what skin tone it needs to give and how it applies to the body. See, this entire man will change now. This old man will change. You see the difference? Everybody can see it, right? You see a different man now? And this is an example. This is the winter road. You see the exact place is the summer road, right? This is what the machine is dreaming. And the vice versa. You provide just the summer road and feed in how the winter looks like for the Switzerland or any place, and it detects, it dreams of the place similar to the winter, similar to the summer. Okay. This is a very interesting concept. Is anyone aware of this artificial mimicking? No one? Is anyone aware of the making the dead alive, the concept of making the dead alive? This is a very good concept which is shared by my friend Aishman Das. So, this is a very good concept that has come to the market. You see this video, this is Mr. Obama, right? The ex-president of the United States.
It got me thinking about my full-time
This is the original video.
Ability to survive on
and what he is speaking is original.
New York City.
Okay? It is his tone. But this video is faked. You see the exact words he is mimicking
Most of us don't get our healthcare
is not the exact words which he is speaking at that moment.
Or through Medicare or Medicare.
So what the machine did, it marks the lips and the orientation. If I'm saying hi, how the lips will look like. It makes the orientation. Now we can mask this part to the Obama's face and feed in any audio or any text, and it will speak the same thing which we want to that mask to speak.
Some progress, at least within the small
this was long back what Obama spoke.
I think it's real important.
This is the current video, what he is speaking when he was speaking back then. This is someone different and he is speaking his words. So this is how we can make the machines dream and make the dead alive. Suppose I die tomorrow and my wife misses me. What she'll do? She'll pull out my letters and my image, and she will feed into the machine, and I'll start speaking for her. Right? This is the concept behind the machine, making the machines, making the dead alive.
This video was publicly taken,
Now,
yet it does not conflict with
before this
EU
say-
privacy.
So this is privacy control. What it is we have seen the object detection, the human face detection, and all. We are all aware of this concept, right? But there is a privacy which comes into picture. Like, I don't want my face to be seen by everyone, right? Why will I? There are cameras installed for this hockey match, and everywhere Bhubaneswar has totally changed. You see everywhere cameras are there. They're seeing you, right? Do you want your face to be seen by everyone? No, right? I may not want. I'm not a hero. So what it does is, this is how beautifully the machines have dreamt of. Yeah.
This video was publicly
If you can
taken,
properly
yet it does
see,
not conflict with
The
EU
face
privacy
is not the
regulation.
exact face.
That
If
is
you can closely
possible by
see-
deep natural
Can you observe
anonymization
it?
of faces.
Did you observe that? The face is not exactly the same. Okay, I'm playing it again.
This video was publicly taken, yet it does not conflict with EU privacy regulation. That is possible by
Did anyone observe that? This face, there is some anomaly, right, in this face. But this machine is so precise that you could not detect at once that this face is a fake face. What the machine does is, it takes the orientation of everybody's face and it masks with a face which machines generate out of it. Now machines started dreaming in such a way that they can generate so many different faces. Now God was making us, but now machines have started making, humans. You see how it does.
This video was publicly taken, yet it does not conflict with EU privacy regulation. That is possible by deep natural anonymization of faces and other identifiable. Deep natural anonymization begins with finding all faces and main attributes of the person. We then understand the shape, mimics, and the overall geometry of every face. With all the
So it takes all the attributes of the face and detects, generates the face out of it and it masks it. So the privacy is controlled in this case. All of you clear on this? Okay. So how do we make machines dream? If I can say, I followed a backpropagation funda. Like usually we see the theory and then the practical. I wanted you to see the practical, then come to the theory, so that you get to learn. So deep learning, as my friend Jayant has already shared, deep learning is a subset of the machine learning, which is a subset of the artificial intelligence, right? So deep learning, what it is, I have highlighted that main part, which is actually the concept behind the deep learning, that is that attempts to model high-level abstractions in data. Now what is that? You see this image. Has anyone ever seen this image? No, right? So this is an Audi car or any car you see. Now the object detection, how it is done. What it does is, it makes granular level of abstraction. What it does is, you see this? This is visible to everyone. What it is it sees the edges. You can see the edges, you can see the tires, right? Whatever it sees, it makes the granular level of edges and granular level of object detection, whatever it can, to the granular level, to the lowest level, okay? And then another level of abstraction, this is a wheel, this is the the windshield or the bonnet, everything. You're getting it? And then finally, it detects, it might be a car, it might be a bus, it might be anything. This is how the abstraction is done. This is how the, you get to detect an object. The machine gets to detect an object. This is the concept behind it. Okay? Clear on this? Okay. Now, where from this, everybody is talking about this neurons, neural network, everything. Where did this concept came from? This came from the human brain only. Okay? So, this is a human brain. This is the anomaly of the human brain, anatomy of the human brain. So, these are the dendrites which receives the information, okay? This is the cell body which, makes the judgment, makes the decision. And this is the axon, through which the message passes and the actual message is, output is given by the synapse. So similarly, this concept was derived from the brain into the machine, which takes the inputs as the dendrites you have seen. You can correlate, right? So this I have given as an activation function, which is a step function, which is like binary, 0 or 1, might be true, might be false, might be real, might be fake. This is a simple example of how an artificial neuron actually works and how it is derived from the human brain. Okay? So this is the concept behind. So what it does is, we give the inputs, okay? Very simple. If you are good in maths, you can get to know, this is the simple inputs which you have given, and this is the weights we have attached to the inputs, because we cannot change the inputs, we can change the weights, right? So these are the weights, and we take the summation of all the inputs and the weights, and we decide. based on the functions. There are sigmoid functions, there are step functions which can be, used to detect what is the output. There can be binary decisions. This is a simple example which I have given. So now detecting a number, okay, that is 5 and 7. The input is given 5, right? Now the neurons, these are the neurons. So these are the nodes. So what it does is, this is the input which we have given, like the 5 is an image, right? What we do is, we convert that into a vector image, and that is the node, the first node. We'll come to it. So this funda which we discussed in the last slide, that will detect if it is a correct function, correct number or not. Now this is the formula for that, the same thing, the summation of the weights and the input which we have given. The simple concept. And the prediction was made 7. Was it right? Is it right? No, right? It's wrong. So what we do is, all we know is an hit and trial method. Okay, this is wrong, let me change this, it will generate something, the correct number. So the same thing is done here. We predict the error. You see the product. This is the, the derivative of the error and the input which you have given, which detects the weight. This is the actual value by which all these weights we can change, we can modulate so that we detect the number. And how it is detected? From this. The error will be the prediction and the ground truth, what we expect and what the value it has given as an output which is wrong. And that weight we will decide from the error and the input, and we change the weights by that number and we get the correct input. This is done by the machine itself. This is how the machine learns. So this is an iterative process until and unless we reach to the correct number, right? So Hubble and WISL, they are the main reason behind this artificial intelligence and the neurons. Anyone aware of this concept? Okay, so what they did is, this is a cat's brain, and what our visual cortex does is, when it sees an object, it detects the edges, and based on the edges, our visual cortex reacts. So that is the concept, the granularity which I said. The first thing we notice, our visual cortex notices is the edges, okay? So so as that number which we detected, right, 5 or 7, that concept I said, right, the inputs, the weights, and we change the weights and we detect the number, right? So this is an image of a cat, right? Now the machine needs to detect that it is a cat. What it will do is, this is an image, right? So this image will be converted into a vector image, okay, and it will be the input layer. And as you can see, these are the nodes which are bipartite. What is a bipartite node? That is, they are not interconnected. Can you see these nodes are not interconnected? But the layers are interconnected. Each node of one layer is connected to the other layers. Okay? You can see the connections. So that is the input and the weights which we have given initially, and this is the node. These are the the predefined data which we have fed into the machine. Based on that, this is the first granular level. If you can correlate to that car's image and the granular level abstraction which we have already discussed. So this is the first level of granular abstraction which it does. From the edges it will detect, okay, this is an eye. The granular level of edges it will detect in this node. And then similarly the next level of abstraction, and then finally the output will be a cat. And this is the output layer. This node will be having the the images of cat, of dogs, everyone. And this node will decide, okay, this is the eye, this is the, and it looks like an image of a cat, right? So this is how the RGB, this is a normal RGB image, right? This is how the RGB image is converted into an image vector. It has a height, it has a width, and the channel, and the multiplied by the 3 of them is multiplied, and one, suppose this is a 28 cross 28 pixel of an image, right? So the channel vector is any value, and the image vector will be decided by the 28 cross the channel value. Okay. Can you relate to something? Yeah. So if everybody has seen Doom 3, right? So what Amir Khan was doing is, he was making a move, and what I have not mentioned Uday Chopra here. So what Abhishek Bachchan is doing is, he detects like, okay, he's going to make this move, and finally, sometimes Abhishek Bachchan's wins and sometimes Amir Khan was winning. So this is how the game theory or the machine is doing the things. If you can correlate, like okay, I detected 7 for the first time, but I need to detect 5. How the algorithm works so that the machine can be the best in detecting the objects. So what this concept is, he makes the move such a way that the police doesn't get to know that okay, this might have happened, because it is thinking the police might think in this way, so I'll do this way. So this is the concept behind the machine dreaming and the machine learning. Okay, now the main concept comes as generative adversarial network. This is the main concept behind every machine, whatever we have discussed, the artificial mimicking, the autonomous driving, everything. Okay. This is the generator. The noise vector is the input which we have given. Okay, and if you can relate to that flow which we have made, observations to patterns and to decision. But what was dreaming? From the pattern making the observations, right? So this is what is done. The machine is asked that, okay, these are the patterns which we have, you start making observations. So this generator is the machine which made these observations from the patterns. And how we decide the observation which is made is right or wrong. This is normal machine learning. If we feed in this image of a petal or a flower, it will detect if it is a flower or not. But what it has done is, from the patterns of the flowers, we have the patterns of the flowers, the machine has, right? From the patterns of the flower, it generated, okay, this might be this flower. And then how we verify? We verify through a discriminator, which is normal machine learning. So what it does is, this is already the data which is there in the model. And then it relates, okay, if it is a real flower or not, if the machine has dreamt of a correct flower or not, from the patterns which we have. The machine, we have fed in so many data to the machines, right? Now it is time that we want machines to, see from the data, think from the data, what we can generate, what we cannot. Okay, see a different world. The sci-fi movies which we are seeing, like some earlier speaker said, that the sci-fi movie which we are seeing now might be a reality for the generations coming up, right? Now, okay, so the concept which I shared, that with the GAN network, generative adversarial network, so this is the noise which we are giving. You can relate to that. You see that noise and the generator, and it detects, it makes the observation from the patterns, right? Okay, so what we were doing is, we fed in 2. We write 2 and the machine was saying it is 2, right? Now this is machine dreaming. These are the patterns which we have already made. We have given 2. Now in current state, machine knows that this is 2 and these are the patterns for 2. But now we give the patterns. Let the machine think what the patterns, from the patterns what the number is. Okay? So these are the different kinds of, if I generate a new noise, everybody's handwriting is different, right? So I am detecting 2 and these are the patterns for the 2. Digit 2, and see, these are the different kinds of, values of 2, handwritten values of 2. This is what the machine is making the observations from the patterns. Getting? I've already said, right? This is the concept behind, the GAN is the main concept behind a machine dreaming. Okay, now who is this? This person is Albert Einstein, right? So the impending concept which we have seen, now we can change the Mr. Albert Einstein to something different. Let's see what it generates now. So these are the places which is being masked by us, and the machine knows exactly what it needs to replace that place with. It's a different man name, right? So as we saw that the masks, these are the humans or the faces which the machines have made out of their own. The machine knows a human face has an eye, has hair, has a mouth, and these are the faces the machine is making out of it. These are completely a different face. Maybe God also doesn't know that, they need to consult the machines that what kind of a face they need to, produce babies out of it. Okay, so this is what artificial face generation is and how the machines are dreaming right now. And from the patterns, from the observations, everything correlated, and the data which we have fed into the machine is actually dreaming. Okay, this is just the beginning. Maybe in some time, or down the line 10 years, the world will be a different place to live in, where the machine starts dreaming and you don't dream. You need to dream also. Let the machines dream. I don't know what state we are getting into, but this is a bit beautiful time. So that's all from my side, and all about machines dreaming.